Thank you, Manuel, for the very generous words. I'm not sure who you were talking about, but I hope not to disappoint with this talk. I have lots of slides, maybe too many, and I will rush through some of them. Partly because the most interesting to me at the moment is the last part of the talk. So I definitely want to get there. Before starting though my tour de force, I would like to thank the organizers of this conference here in Toulouse. We were saying that this is almost the ideal place to hold a conference like this. The organization has been very effective, and the people I've been talking to. Unfortunately, I haven't been able to go to many sessions because of the meetings involved with my responsibilities. But I hear that is going very well. So today I'm going to talk about the determinants of human capital formation during the early years of life, in particular in developing countries. I should say that I will try to weave a story using a number of projects that I've done with a variety of co-authors. The one in blues are papers, some are published, some are being written, some are very, very preliminary ideas, but the blue ones are the ones from which I will take directly material from, and the black ones are background or related papers, projects we have been working on. And so the Colombia study is going to be quite a recurrent theme because we've been working there for now 6 or 7 years on this latest adventure, and it's going to be used quite a bit. But other things. The new stuff is the beliefs and distorted production functions. That's what I would like to really get to. And a recurring thing is going to be measurement. So I will try to say something that I hope is substantive about measurement. So I have lots of intellectual depth, and here are some people and some projects, some papers that definitely affected and started me on this new research agenda. Sally Grantham Macgregor, for those of you who don't know, is a child development scholar who was the inventor of, she did the Jamaica study with some colleagues that has, for me, has been extremely influential in shaping what I've done. And I guess I don't need to tell you who Jim Heckman is, but his influence. The paper that was presented, the Frisch Medal yesterday, has been quite important. And finally, on the measurement stuff, the work that Chuck Mansky and older people like Tom Juster, one of the founders of the PSID, have done on eliciting subjective beliefs and attitudes and expectations has been quite relevant. So this is my outline. I will start with an introduction about the early years, talking about some successful interventions in affecting the child development. Then I'll talk about briefly about what I think we know and what I think we don't know, and then move on to try to sketch a theoretical framework to tackle these issues. And then I'll try to put this model to use using our Colombian data. I'll first describe some impacts and then move on to the estimation of the model. And I'd like to go on to 2 digressions, one on the use of structural models in randomized control trials, which is in development economics, has received quite a bit of attention, and then my stuff on measurement. Then I will talk about beliefs and distorted beliefs and the like, and finally conclude. So there has been quite a bit of work in recent years. Jim Heckman has been very influential in pushing this on human capital accumulation in the process of growth and development and as a way to reduce inequality and increase equality of opportunities. A theme that has been recurrent is the fact that human capital accumulation is a very complex process. We understand now human capital is a multidimensional object. It is made of many dimensions that probably interact in a complex way during the process of formation and growth of human capital. And the process starts very early in life. The early years appear to be very important, and what happens to people in the first 1,000 days of their life seems to have very important consequences in the long run. Early years seem to be at the same time vulnerable and malleable, which is another way of saying that bad shocks have dramatic effects, and good shocks and good interventions can change things. And therefore, this year seems to be particularly salient for the design of public policy. Now, it doesn't mean that everything is fixed by age 3. Other policies probably are more effective, but I will not talk about that today. Children vulnerability and policy intervention seem to be particularly relevant in developing countries where risk factors are particularly salient. According to the Lancet series that Sally directed, one in 2007, one in 2011, there are an estimated 200 million children in developing countries. The map shows with colors where they are, that are at risk of not developing their full potential. Why? Because there are lots of risk factors that seem to be particularly relevant in these countries. There are biological factors, and nutrition. Undernutrition is prevalent both before birth and in the first few years. There are infectious diseases, environmental factors, and psychosocial factors. Stimulation, parenting, and responsiveness of caregivers can be very low quality, and there is violence, there is maternal depression, and other factors. And these are have very strong impacts. This is some data from Ecuador. This is a paper by Chris Paxson and Norbert Shadi, published in the JHR. This is data from Ecuador. These children are divided by according to the wealth decile of the family, and are followed in their child, and these are language development from age 36 months to age 70. And you can see that by age 6, children in bottom quartile are 3 standard deviation below in standardized scores than children in the 4th decile. I'm not talking about the rich children. These are children in the 4th deciles. 3 standard deviation is a dramatic delay. If you translate it in terms of years, corresponds to a 2.5 years delay. So a child is 6, is starting going to primary school, and he has a language and probably a mental development of a child of the age of 3. So he's not going to learn anything, and he's going to fall behind and stay behind. And the same is true in Bangladesh. This is data from a paper that we're publishing in pediatrics with Sally and some of her collaborators. It's a high-quality data that follows children starting at 7 months, then at 18 months, and at 60 months. And you can see that in terms of IQ, you have a detectable difference already at age 7 months, and those increase quite dramatically as the children get old. And these are, again, differences across profiles. These are data from Bogota in Colombia. These are the dotted lines are children in the bottom quartile, and the dark lines are children in the top quartiles. We already observed significant differences at age 12 months in various dimensions: cognition, receptive language, and expressive language, and this, again, this fanning out of development across children of different socioeconomic background. So it's pervasive, it starts very early, and increases over time, and is in many dimensions of development. Now, something has been done in a variety of contexts, and there is evidence now that early years are malleables, and that implies that well-targeted policies can make a difference. There have been a number of interventions both in developed and developing countries. For instance, these are some programs in the US. I will not have time to go through the details, but some of these interventions, like the peri-preschool program, the Becedarian program, and others, these children have been followed for 40 years. This is fairly rigorous evidence based on randomized control trials. They showed long-lasting impacts well into adulthood in a variety of dimensions, including health outcomes. And in developing countries, these are some of the studies that Sally has done. The first one, probably the most famous, in Jamaica, and then the one in Bangladesh. And in Jamaica, I just wanted to reproduce some of the results. These were 129 stunted children that were divided randomly in 4 groups, receiving different types of intervention, stimulation, nutrition, or both. And the amazing thing about that study is these children were followed over time for many years. And these are the results. These are the results during the study. The intervention lasted 2 years. So these are non-stunted children. And this is the control group. These are the stunted children who receive both the nutrition and stimulation supplementation. So these are impacts that are massive. And when I first read this paper, this for me was a big motivation to go into this field. This is from baseline until 24 months. So these children started very young into this intervention. And this is over time. So this is now it's just the difference between stimulated and unstimulated children. This is at the end of the intervention. It's the same picture as before. This is 7 years. This is 12 years. This is 18 years. Recent paper by Jim Heckman, Paul Gertler, Sally, and others show the outcomes on labor market outcomes. It just came out in Science a couple of months ago. So this is the introduction. This is where we stand. I think over the last few decades there are lots of things that we have learned in this field. We know that human capital is a multidimensional object. We know that early years are key. We know that nutrition is important. We know that stimulation is probably even more important. And the household environment is crucial. I did not show you evidence of that, but trust me in this one. And there seem to be important dynamic interactions in the various dimensions in which human capital develops. There is still lots of stuff we don't know. For instance, an area that is receiving lots of attention and lots of interesting studies is the effect of genes and epigenetic processes and how they affect the multiple aspects of development. There are some really interesting studies, and there's still a lot. It's quite controversial, and it's still a lot that we don't know. We do not fully understand how nutrition itself. That's something that really surprised me. If you look in the literature for definite answers, say, on what's the effect of anemia at age 2 on subsequent cognitive development. Well, there is not a definite answer to that. There is still lots of both results and mechanisms that are not fully understood even at the level of biology, which sometimes lead to really contradictory public policies. For instance, for a while, they were saying, oh, we need to give irons to anemic children, and then found out there was a study in Tanzania that found out that if you do that in an area with endemic malaria, you risk to kill these kids because of the interactions of iron with parasite. We still do not understand the nature of the interactions of different aspects of human capital. Jim has been very forceful in pushing the effect that non-cognitive skills, as they're time called, have on subsequent development of cognitive skills. It's true, it's probably true, and it's probably very important. We still need to quantify much better this type of effects and how they evolve over the life cycle, and especially in the early years. Partly this is due to the lack of good measurement, and I'll come back to the issue of measurement later. And we still do not understand the role played by different inputs and their interactions. What can parents do or public policies? And talking about parents, we still don't understand how. We know that they are important, and your subsequent life, you better choose good parents. But we don't know how they behave. We don't know what constraints really determine investment behavior by parents and how resources are located within the family. And finally, and this is something that I came to appreciate doing this work in Colombia, is the evidence I mentioned before on the interventions. These are fairly small studies and almost efficacy trials on specific interventions. Developing effective intervention at scale with the existing resources and with the existing infrastructures, especially in developing countries, is still not clear how to do it. So I think that's a really good research agenda. It's not something I will talk about today. So to address some of these issues, I would like to talk about sketch a theoretical framework. That's where I use some of the material that Cunha, Heckman, and Shenak have developed in their econometrica paper that was that received the prize yesterday. So the H is the notation here. H is human capital at age t plus 1, which is a function. The function is age dependent, depends on the level of human capital, on investments, and on other background variables and some random shocks. Now, all these variables can be multidimensionals, and that's the notation. So in this particular case, I consider 3 factors for the development of human capital: the cognitive factors, socio-emotional factors, and health factors, which is a little bit of arbitrary, but you could, that's a start if you wish. And these are backgrounds like parental factors, environmental factors, and then investments that could be in time or materials or commodities, books and toys and the like. So parents, what parents do, they choose investment to maximize utility. Assume that utility depends on the current consumption by the parents and can you please move the little hand from the, yeah, thanks. And on human capital, subject to a budget constraint, so I have a vector investments that depends on price and some resources, and the process of human capital accumulation, or at least, and I'll come back to that, to this issue, this is going to be the center of my last part, what they perceive the production function of human capital to be. So, so investment could be in commodity and times, and we could easily add to these labor supply choices. We could easily add more complex intertemporal dimensions, for instance, to introduce liquidity constraints and the like. But for what I want to do today, this is enough. Now, what Flavio, Jim, and Suzanne do in their paper is which is one of the reasons why I like it, is that if you go back to the slides and you want to bring this to data, you don't observe any of this stuff. These are all latent factors that we do not observe. So what they do is to supplement the structural model with a measurement system. So we observe bunch of variables, measurements, DMs, which just are assumed to be related to the latent factors through this measurement system, and then you can work and derive the identification results under what conditions you can identify obviously you need to impose some structure to identify the joint distribution of these latent factors. Here is written in a specific way, can be generalized in some dimensions. Effectively, what you need at the end of the day is you need some exclusion restrictions. So you have to have some measurements that are affected by some factors but not by others. You need some independent measurement error. The measurement error of different measures has to be independent. Now, I want to pause for a second on this because when I'll be talking about about measurement, these assumptions that can be strong given a set of data, you can actually make them more plausible by constructing your own data. And so this is the point I want to come back to. So parents choose investment in reactions to shocks, and the structural framework that we designed, that we sketched, suggests a solution on how to deal with this problem, the endogeneity of investment. So what you do, you derive an investment function. In that specific problem that I wrote, the investment depends on resources, on prices, and on other factors. Again, you can estimate that together with the production function. Here, for identification, I need to, again, to assume some restriction. I need some variables that enter the decision, the investment decisions that do not affect production directly. prices is the obvious choice. And I'll come back to this point later. And if you don't want to be very specific about preferences and about deriving the investment functions, you can do a reduced form for the investment function and then correct for the endogeneity investment using some sort of control function approach to estimate the estimated production function. But you know, the role of the model, and you need to think about what parents do to specify, at least implicitly, a model for investment. That's the message here. And that's why the variables like prices or total resources that are excluded from the production function and determinant investments play a crucial role. Now, the parameters of the investment function will depend on the parameters of the utility function and the parameters of the production function as perceived by the parents. And again, I'll come back to this issue later, but do keep it in mind. Estimation can be performed in 2 steps. This is some work that we have done with Costas Macgregor and Emily Nix, who is a graduate student at Yale, to develop some of these techniques. So you first estimate the joint distribution of the latent factors and then draw from the distribution to estimate the production function using some sort of nonlinear least squares or control function or whatever. And you can do inference by appropriate bootstrapping of these objects. So let's see how we use this model. As I said, a few years ago, we started this intervention. Manolo mentioned that I've done some work evaluating different interventions and welfare programs in Latin America. This is the first time where we didn't do just the evaluation, we actually designed the intervention. We implemented it on a fairly large scale, so it was a completely different ballgame. It was very exciting, and but it took some time. It took a few years. So I will describe the intervention. We'll report the impacts. Because I'm going to use a randomized controlled trials, the impacts are very easy. Effectively, I'm comparing means. I have control and treatment. The impact of the intervention is the difference between the two. However, then I move on and I try to use the same data to estimate the production function and the investment functions that I've been describing, and I will discuss why this is useful. It's not just a macho thing of estimating a structural model and showing that you can do it, but it's actually useful to understand and eventually improve the design of the intervention. So these are results from a paper with Sally, with Camila Fernandez, Emma Fitzsimons, and Marta Rubio and Costas. The intervention consists of home visits. This is basically a copy or an adaptation of the curriculum, of the Jamaican curriculum that Sally developed 25 years ago. So these are home visits. We have a visitor that goes to the home of these kids and plays with the mother and the child once an hour every week for 18 months. It sounds very soft. One thing that I learned working with Sally, that actually the design of this thing is not trivial. There is a lot of thought that goes into this. Focuses on cognition, language, and fine motor skills, and the children are aged between 12 and 24 months when we start the intervention. What are the innovations relative to the Jamaica study? A big one, which is relevant, it's not the focus of my intervention, but I do think that it's an important point. It's not the focus of my talk today, but it is an important point. The intervention was delivered by local women, which we identified through a pre-existing welfare program. So we made a real effort to design this intervention in a way that could be scaled up. It's not an efficacy study. It aims to be an effectiveness study. It lasted 18 months, and we collected rich data to be used to explain the impacts of the intervention. So we evaluated with a cluster randomized controlled trials. We studied 96 towns in 3 regions. So these 3 regions in Colombia have a size which is 3 times the size of England, just to give you an idea of the scale of the project. And so we have about 1,400 children. And just to brag a little bit, this is the largest study in this field. If you think of the Jamaica study, it was 129 children. The Perry preschool program is 111. So these are the sort of numbers that we've been used to. This is 1,400 children. It's true that randomization is done at the level of the village, but once you take into account intra-cluster correlation within the village, which is relatively low conditional on observables, is 0.04, that reduces the effective sample size to 880, which is quite a bit bigger than the others. So I do not have numbers the numbers exist. I'm not supposed to show you the actual table. That's the way medical journals want the publication process to be. So we are in the second round of revisions for this paper. So trust me, the impacts were significant, and both in statistical terms, and they're very robust. We get the impacts on cognition after 18 months and on receptive language. It's not a table from the paper, so I can show that. That's the distribution of this is the density for the cognitive scales, the Bayley's tests, for the treatment in red and the control in blue. So you can see the impact is there. How large is the impact? There is a bullet point that disappeared from my slides here. If you remember the pictures from Bogota in the top quartile and the bottom quartile of the wealth distribution, that the impacts fills in about half the gap, a bit more than half the gap in cognitive development between the bottom and top quartile of the wealth distribution. So it is economically and meaningfully significant impact. The other thing you can do with, and that leads me into the mechanisms, you can check impacts on other stuff, not on outcomes, not on children development, but this is a table with impacts on inputs. And so we find that the stimulated children, again, we had this is a 2x2 design, so there was a stimulation intervention, a macronutrient intervention, and then combination of both. I do not have the time to go into this, but macronutrients were these little sachets of white powder that you put on food. So we had some interesting experiences there too. And so we find the impacts of the stimulation not just on the cognitive development, but on the number of toys that people make and buy, the number of time that mothers play with their children, the number of play materials around the house, and the like. Which gives you a first hint to the mechanism. But to nail this down, then we go ahead and estimate the model and interpret the impacts. So this is another paper with Sarah Catton and Emla Fitzsimons Costas and Marta Rubio. And the purpose of this exercise is to establish how the intervention obtained the impacts that we observed. And effectively, once you frame the intervention within the production function approach that I described, there are several ways in which you can obtain the impacts. You can make parents more productive. You can shift the parameters to the production function. Or you somehow can convince parents to invest more. So you can shift the amount of investment that they make. And so that's to frame that's you can do it with the appropriate data, with the appropriate methodology. So here we consider this is an investment function that we'll be estimating, and notice that I make all these parameters, including the constant, as a function of the intervention. So I can remember that the intervention was randomly assigned across villages, so I can use almost separately the two data sets. And notice also that the investment function will depend on prices, wages, family resources, and family composition, which is crucial for identification. And then we estimate the production function. We use a CS specification. Maybe we can be a bit more flexible than that. And this again in terms of these latent factors. And again, we can make was very proud of my ability to change colors in Beamer. So I made the parameters of the production function. They have this blue index, which indicates that the kappa is the indicator for the intervention, being 0, 1 in control and treatment. And the red stuff is the stuff that they can change because it's endogenous. That comes from the investment function, so investment in materials and time. Notice that I'll come back briefly to this point later. You know, when I present this material in Cambridge, Massachusetts, or to people of that type of approach, they say, oh, why do you need this? Because, you know, you have the intervention which is exogenous by construction because you allocate it randomly. However, here I want the intervention to affect the production function, to make parents possibly more productive, which implies that I need to get identification from somewhere else. So I need to get variables that move investment which are not related to the intervention. Now, of course, if I find out that the intervention doesn't change directly the production function, then I can get even stronger or more precise estimates by using that information. So these are the results on the latent factors. This is you get simply by estimating the joint distribution of the factors, and so these are cognitive and non-cognitive factors, or socio-emotional factors in treatment and control. So here you see the effect of shifting the distribution to the right. So this is just a check. It's not a big surprise given what I showed you before. You know, we know that the Bailey does it, and indeed this latent factor also shifts to the right. You get a little bit on the non-cognitive skills, but less so. And then when you look at the investment factors, you get this big shift to the right, both in terms of material and time. So we have all these dozens of indicators of investment in time and materials, toys and amount of, we have time use data and all that kind. And this is reflected there. Again, this is not a big surprise given the table I showed on the investments. So this is kind of a reality check for the model. So this is the investment function. I don't want you to look at this number, so I focus on the intercept. So this is, you know, the intercept and the shift by the intervention. And so you can show that you can see that there is a shift, a significant shift, a pretty big one of investment, both in terms of materials and in terms of time that the intervention has. So, you know, this evidence, the intervention did shift what parents do with their kids in a pretty massive way. And this is the production function. Now, there are lots of things to say about these things. First of all, you find these dynamic effects. So this is for cognitive skills. And so this is lag cognition is definitely important. Time investment is important. The first column is without taking into account the endogeneity of investment. Once you take endogeneity of investment into account, the coefficient on investment goes from 0.056 to 0.277. So it becomes 5 times bigger. And this indicates that parents are trying to compensate. So that's why you get a downward bias when you ignore endogeneity. The one thing that is consistent with the results that Flavio, Jim, and Suzanne get on the NLSY is that linearity is massively rejected, but the complementarity parameter is basically 0. The elasticity substitution is 1. Cobb-Douglas is actually a pretty good approximation of this. Yeah, that's the time, the cognitive factors, and it's the production function for the non-cognitive factors. And here you can get some so it's the other way as Jim's results. We find the complementarity going in this one. So past cognition affects future non-cognitive skills. Now this is a different time different ages. These kids are really young. They're much younger than the youth that they looked at. So let me give you a little two digressions. Okay, the one thing that I need to notice is that if I let the intervention affect the parameters, they don't move. They're basically identical between treatment and control. It's in the total factor productivity, but if you do it for every single parameter, you do not reject the hypothesis that the parameters move with the intervention. Which is to say that the intervention doesn't change the production function. So we're not making parents more productive, more effective. What we are making, we are shifting investment. And that's what explains the effect that we observe. And in fact, if you do the goodness of fit, you recover 80% of the impact from the shift in investment. So why are RCT versus why do we do these structural models? Well, it should be clear by now. RCTs are simple, and you can go to a policymaker and say, okay, this is the impact of this intervention. That's quite simple. Just the difference of two means. That's easy to explain. What is the use of the structural model? Well, it helps us to understand the mechanism through which the program operates. And that, I think, and that was the point, is that we wanted to know how we did it. And the story in this particular example, I think, is pretty clear, and this is a pretty robust result with this shift the way parents invest, rather than making them more productive. And that's key for the design of policy. The structure that we built is also useful to synthesize much information that we have. So we have dozens of measures of child development or investment. And, occasionally people do some arbitrary, construct some arbitrary indexes. I think this is an interesting structure to put this thing together in a nice way. As I said, we do not use the RCT to identify the production function or the investment rule. And the reason for that is because and that's why we need some instrumental variables. We need some variables that affect investment and do not affect the production directly. And we need that source of exogenous variation in the determinants of investment. So let me talk a little bit about measurement, which has become my little obsession over the last few years. Measurement is central to the approach we've taken here. Appropriate measurements can be used to solve identification problems and estimate richer and more realistic models. That's the line that I want to push. However, I also think that much has to be learned in terms of developing appropriate measures. This is not trivial. There's a substantial amount of work that should go into that. So I want to make 4 points. One is that there is much work that is needed, especially in the field of child development, but that's what we've been looking at. I'm sure that the same is true in other fields. The new technologies can and should play a central role in developing new measurement tools. The theory should inform the development of suitable measures, and it might be worthwhile to go beyond the standard revealed preferences approach. So let me go into this. So measuring young children development accurately is very hard. That's something that we learned over the last few years in this project. Probably people in the field already knew that. We used something called the Bailey scales of infant development, which is considered the gold standard. And that's at the center of our study. Now, Baileys are very expensive. It takes an hour and a half per child to administer the test. The test has to be administered by a specialized psychologist that is trained specially to administer that test for about 2 months. And that has to be done in a standardized setting, so you cannot do in the child's home. So it is very, very expensive, and that's why the reason that's the reason why lots of people going around using alternative measures of child development that can be administered by interviewers that take 20 minutes rather than the 90 minutes, and so on. Unfortunately, these alternative cheap measures can be very noisy. So we've done a study, the one that in Bogota, just to test these ideas out. We collected the Baileys, and then the previous week we sent just a normal interviewer rather than a psychologist to the homes of the kids and administer a variety of different tests. And this graph, what reports is correlation with the Bailey Cognition Index. By the way, if you do a factor analysis on the Bailey's test, the signal-to-noise ratio is the highest of all the measures we have. Now, and then what you find is that, the ASQ, Ages and Stages Questionnaire, which is something that the World Bank has been sponsoring, is being used all over the world. Well, for children below the age of 3, which is this age here, 36 months, the correlation with the Bailey is below 0.1. And this level, I don't have it in this graph, but it's not statistically significant. You know, you can get up to 0.5, but this is a different test. This is the Denver language test. So these measures are not very good, and there is lots of scope to improve on that. And that's correlation with Bailey's expressive language. Expressive language is easier to measure. You know, lots of these cheap tests are based on maternal report. So if you ask these very poor mothers stuff about what their children do, which is the ages and stages, they're not very good at answering those questions. However, one thing that they're okay is, if you ask them, can your child say dog? Can your child say house? So they know that. And that's the purple line, this MacArthur language inventory test, and which does okay. This is a correlation of 0.6. So if you're interested in language, there are cheap ways of asking it. But for the other stuff, for cognition, it's really, really hard. So I think that's my second point. There is much need for new tools. And indeed, new tools are being developed. One of my colleagues at the UCL, at UCH, the University College Hospital, is a pediatrician called Neil Marlowe, who has developed an index called PARCA-R. Was originally developed for premature babies. He has a couple of papers in which he shows correlation with the Baileys of 0.8. For slightly older children, but still, that's pretty good. There's a psychologist at Stanford called Anne Fernald who's been using eye tracking tests, and they seem to have very good predictive properties for later academic outcomes of children. And the beauty of this stuff that it can be done in 10 minutes using computer technology, and it's quite neat. Recently, I've been talking to Sarah Fox-Lloyd. There's another colleague she's from Birkbeck College, and there's a team between Birkbeck and UCL. And they do this thing called functional near-infrared spectroscopy with portable devices. So this is like a portable fMRI. So it's a little helmet. You put it on the child's head, and you measure the brain activity. And they published just a couple of weeks ago a paper in Nature in which the purpose of the paper was to show that this could be done in very remote places. So they did it in the Gambia. And so this is all very exciting. We still don't know exactly what they're measuring with this stuff, so there needs to be some validation work. So I know if I do peekaboo to the kid, a certain region of the brains light up, but what that means in terms of development is not completely obvious. So there is work to do, but I think we're getting there. And I think there might be some low-hanging fruits there to be had. So then my third point is that problem measurement tools can solve identification problems. This is obvious when some specific kind of observables become partially observable. There is a more subtle sense in which appropriate designs can help identification, and that was the point that I was trying to make there. In the factor models that we've used, non-parametric identification requires multiple measures with uncorrelated measurement errors, for instance. And then when you go to the field and you design your questionnaires, you might want to decide to have one measure with administered by a psychologist like the Bailey, and then another measure, maybe the MacArthur test that are okay, that is done by a different person on a different day, asking the mother rather than the child. Then assuming that measurement error of those two components is uncorrelated, it's probably much more plausible than two measures taken by the same individual on the same day on the same child. I guess the point I want to make is that you can put some thought into this and design surveys and instruments that where the hypothesis that the theory needs are more likely to be satisfied. Now, this is obviously not particularly new. Suzanne Chenack has got a paper about 10 years ago in Econometrica in which she looks at multiple measures to deal with measurement errors. And it's related, Martin Browning and Tom Crossley have they've been working on measures of consumption. Two noisy measures might be better than one. And the argument is the same thing. You average out measurement errors. You can do things with these things more effectively. Given that probably the perfect measure doesn't exist. Finally, the last point. And that's what we tried to do in the Columbia study. So we have measures that were done by the Bailey scales that were done by the psychologist. We have the MacArthur language test. We have a bunch of other things that were based on maternal report, and so this can be good. Similar things are for the exclusion restrictions. Now I'm doing the stuff on measurement error. Andrew's here, so I need to mention those things. But the same things you can do in terms of exclusion restriction, loading different factors and different measures. You can construct the appropriate measures for that. Now, beyond revealed preferences. So another dimension which I think measurement tools can be developed is by eliciting individual responses on expectations, beliefs, tastes, preferences, attitudes. Now, this is I've done a bit of work on this, and I've had a reasonably hard time publishing this work. Lots of economists have a very strong resistance in going beyond revealed preferences. So asking people, about their subjective stuff, it seems to be not well received. But I think if you are careful enough, and if you are ingenious enough, it can be done. And so that's obviously has been pushed a lot by Chuck Mansky in the context of subject expectations. There's some old work by Tom Juster in Michigan, and, when they were starting, even before the PSID, which is actually quite clever, very beautiful stuff. And he was doing this stuff on trying to test liquidity constraints and giving people different menus of credits to buy cars. It's an old paper that he wrote in 1964, which I don't think was ever published. I saw it as an NBR working paper. And they're related to the stuff on willingness to pay, too. So this is some stuff that Flavio Cunha has been doing recently in Philadelphia, asking parents about the return to parenting investment. This is a hospital in Philadelphia with young mothers. And with Flavio, we've been talking, and in the last field work that we've done in Colombia a year ago, we've done it. So we use tablets. And so these kind of tablets, really made of wood. And so what we do here, we present these mothers different scenarios. If every little rope with a bead is a different scenario. And we ask, okay, when does the child start saying these words? So these are, you can't see it in the picture, but there are months. And so she moves the bead to the answer that she thinks is appropriate. And we choose the words judiciously. So these are words taken from the MacArthur language test. So by doing factor analysis on those words, we can choose the words that are more salient to reflect the development of the children. And then we let them do, and we vary the difficulty of the words. We vary the investment of the child. So suppose that the mother spends 2 hours a day. Suppose that the mother now spends 6 hours a day talking and playing with the child. When does the child start saying dog? And we vary the initial conditions. We vary how the thing does. And that's a matter of doing that stuff. So they, can be done. It can be done, and we're starting to look at this data. I have one table, is the last thing I will show you, where this data seems to be meaningful. So let me talk about beliefs now. So that's what we're trying to do, is to elicit beliefs. I need a little bit of water. So there are a number of interventions that have an impact without providing the individuals, the beneficiaries, any resources. We just give them information. The one we did in Colombia was an example. We give information about appropriate parenting practices. There are others. With one of the papers I was citing, is an intervention in Malawi where you give nutrition information to parents, and has an impact on the growth, on the physical growth of these children, without providing any resources. So in Colombia, the results that I showed you and have been claiming that they're very robust seem to indicate that we got those impacts on the cognitive development of children, not by changing the production function, but by convincing parents to invest more. And so the next question is, okay, why is that? Why didn't they do it before? Why we're not investing? And so if you go to the model that we've been using, is that they still probably maximize. They love their children. It's not that they don't love their children. They love the children, but they're still maximizing some utility function with some budget constraints. And then they use the wrong production function. So they have the wrong idea about the production function. So their investment depends on their resources, on their tastes, but also on their perception of the production function. So one hypothesis is that this type of results is driven by misperceptions of the production function, and particularly a misperception of the productivity of investment. So I'm doing some work with Sarah Catton on this. And so suppose the parents maximize utility subject to a budget constraints. I'll give you an example. This is very parametric. Some of you won't like this stuff, but it's very simple. It's useful to understand what's going on. So I'll assume that the utility is the sum of two power functions. The production function is for human capital is Cobb-Douglas. I'm only having one factor, so I'm stepping back from the more complex stuff, but it's useful to make the point. And so here, the second line is the budget constraint. The first is the utility function. The third line is the true production function. It's what actually determines human capital accumulation, which is the initial condition and the investment. And the red one is what they act upon, is their perceived production function. And so you can substitute budget constraint, you derive the first order conditions, and you get the investment function, which is in logs, is this expression here. Now, these choices are not necessarily optimal, unless the alpha tilde, the production, and the beta tilde, which are the productivity parameters perceived, are the same as the true one. So how can we identify these distorted beliefs? So the most obvious is the elicitation of preferences. That's the stuff that we're trying to do with Flavio and one of my students, Pamela Hervis, in Colombia. But that's not what I'm going to talk to you about today. We just got this data, so we haven't used them much. We can use the interventions where information provision is successful to identify distorted preferences. Obviously, I don't observe the distorted preferences or distorted beliefs, so I need to make some assumptions. So what I do is to use outcomes on human capital development and investment choices of the informed parents to identify both the production function and the taste parameters. And then once I know the taste parameters, I can use the investment choices of the control parents, the one that do not receive the intervention, to identify their idea about the distorted production function. If you remember in an earlier slides, I said that the investment functions that the parents make, the parameters depend on their tastes and their perception of the production function. I identify the taste from the revealed preferences of the informed parents, those who receive the intervention. Once I know the taste, I can disentangle the perception of the production function by the control parents, so the distorted production function. So here the RCT is very useful because I've been allocating the intervention randomly, so the treatment and control parents are identical by construction on average, and therefore I can assume that the taste is the same. The taste parameters are the same, which is then used to identify this. And so that's how we do it. So this is the how the reduced form parameters relate to the structural parameters. The beta k now is the perceived, and the alpha k is the perceived production function in the investment in the production function, or in the treatment and control samples. And so, if I'm willing to assume that what the intervention has done is to reveal to the treated parents the true, that's the strong assumption, right? I need to put some structure somewhere. So I assume that the intervention has revealed the true production function to the treated parents. If I'm willing to make that assumption, then I can identify the ratio, how distorted the marginal product, the perception of the marginal product of investment we have. So we can estimate the true value of the production function can be estimated directly relating outcomes to investment, taking into account the endogeneity as we did it before, and for such a purpose we can use both treatment and control samples, and indeed it's more efficient to do so, as long as you let the investment, the first stage for the investment, to be to vary completely with the intervention. But then if you're willing to assume that the treatment does not affect the production function, you need additional instruments to identify the production function parameters. And so these results are very preliminary. I mean, literally 2 days ago. But that's, if you translate the fact that in the treatment sample they invest more in terms of times and toys and materials for the kids. So the productivities for the productivity of investment is underestimated by these poor parents. So it's 0.84, and on the other hand, the productivity of the initial conditions, the effect of initial condition, is overestimated. This is consistent with anecdotal evidence. I've been going around these places talking to parents, and one thing that we've been doing this similar stuff in India. It's amazing. They all say the same thing. Our curriculum stresses language, and you say to the mother, you should talk to your child, you interact with him or her, and they all tell you the same thing. They say, "Oh, why would I talk to her? She doesn't understand what I say." And so they don't seem to be aware of the impact that stimulation has. And so they definitely, unless they have a problematic child. So that when you encounter households and you talk to them and say, when do you think it's important? And they say, oh, if the child has got problems, then it's useful to intervene. But if the child is not problematic, then it doesn't need the help of the parent, doesn't need the stimulation, doesn't need the intervention. And it's also consistent. There is an interesting book by an anthropologist called Annette Lareau, who also works at Penn, I think. It's called Unequal Childhoods. And she analyzes the lives of children living in middle class versus working class or poor families in the United States. And she proposes two alternative models, and parents of different socioeconomic background use it. In the middle class family, think of what she calls it concerted cultivation. So the kids go to soccer school and to violin classes, and they talk and they do all sorts of things. And then the working class and poor families, they have this natural growth. So they let the child be, and he or she will grow fine with not much problems. So I think this is very encouraging, and it's also consistent with some preliminary evidence. That's my last table. This is really preliminary. These are the new data we're getting on the elicitation from moving these little beads on the tablets. And what it shows here is that we compute the return to investment as how many months, so when does the child start saying this word under low and high investment. And so that's the 1.21 is the ratio of the two ages. And you can see that the return is much higher for the less developed, so for the low initial condition child. So this is completely consistent with this story I've been telling. And we'll see what this data will reveal once we have more time to analyze them. Okay, so I have my concluding slides. I've been doing great with the time, I think, just on time. So the study of human capital accumulation is important, especially in the context of developing countries. I think we have learned much, and we know that early years are important, we know that early years are malleable, we know that targeted and well-designed interventions can be effective. But there is still much work to be done. The process of human capital formation is complex. We don't fully understand the dynamics of it, the role of nutrition, the role of genetics and epigenetics into the various dimensions. And what I think is probably the most interesting thing is what do parents do and why? We know parents are important. We don't completely know how to describe, and therefore affect, if necessary, their choices. And this is something I haven't talked a huge amount about, but I think it's not just a policy question, it's a serious research question, is how to build scalable interventions. And that is not, scalability doesn't mean just resources and money. It depends also how you implement on the ground, in the field, the interventions, taking into account this kind of beliefs and attitudes that people have. And I think that's key to scalability of interventions. Research agenda, better measurement tools. I think there are some really important work that needs to be done there. The use of structural model to identify the production function and parental behavior is instrumental to the design of effective policies, and that's where we should be going. Thank you very much for your attention.